Hello everyone. Now we are starting the next part of media access control. Next point is carrier sense multiple access, that is CSMA. The CSMA protocol operates on the principle of carrier sensing. In this protocol, a station listens to see the presence of transmission carrier on the cable and decides to act accordingly. There are the CSMA types. First is non-persistent CSMA. In this scheme, if a station wants to transmit a frame and it finds that the channel is busy, some other station is transmitting on that or over that channel, then it will wait for the fixed time interval. After this time, it again checks the status of the channel, and if the channel is free, then it will transfer. Next is one persistence CSMA. In this scheme, the station which wants to transmit continuously monitor the channel until it is idle and then transmits immediately. The disadvantage of this strategy is if two stations are waiting, then they will transmit simultaneously and the collision will take place. This will then requires the retransmission. And last is P persistent CSMA. The possibility of such collision and the retransmission is reduced the P persistent CSMA. In this scheme, all the waiting stations are not allowed to transmit simultaneously as soon as the channel becomes idle. A station is assumed to be transmit when the probability P, for example, if P is equal to 1 by 6, then and if 6 stations are waiting, then on an average only one station will transmit and other will wait. Next is carrier sense multiple access collision detection. The carrier sense multiple access collision detection specification have been standardized by IEEE 802.3 standard. It is very widely used MAC protocol. MAC is the media access control. The problem in the CSMA explained earlier, that is transmitting station continues to transmit its frame even though the collision occurs. Channel time is unnecessarily wasted due to this. In CSMA CD, if the station receives the other transmission when the transmitting, then the collision can be detected. As soon as it occurs, the transmission time can be saved. As soon as the collision is detected, the transmission station releases a jam signal. The jam signal will alert the other station. The station then are not supposed to transmit immediately after the collision has been occurred. Otherwise, there is the possibility that the same frame would collide again. After some back of delay time, the station will retry the transmission. If again the collision takes place, then the back of time is increased progressively. A careful design can achieve efficiency more than 90% using CSMS-CD. This scheme is shown in the figure. In the figure, A channel, A listens the channel appears a quiet, A starts transmission. Then A is transmitting the data. Then A signal reaches to the B, blocked by the transmission by the B. C listens, the channel appears quiet, the C starts the transmission. A and C both are transmitting now, and then collision takes place between the A and C. You can see in the diagram, the blue part is shown as the collision and transmission is shown in the gray part. Then C detects the collision, stop its transmission and sends the jam signal, and then A continues to the transmission. And then A detects the collision and stops its transmission and sends the jam. First C will sense the jam and then A will sense the jam. And lastly, no station is transmitting, but there are still signal on the bus because the channel has the collide data in it. Next is the CSMA procedure. The following figure shows the CSMA. The station has a ready frame set the back of the parameter to the 0. Then it senses the line using one persistent strategy. Then it sends the frame. If there is no collision for the period corresponding to the one complete frame, then the transmission is successful. Otherwise, in the event of collision, the station sends the jam signal to inform the other station about the collision. The station then increments the back of time and waits for the random back of time and sends the frame again. If the back of has reaches its limit, then the station aborts the transmission. CSMA CD, that is collision detection, is used for the traditional Ethernet. CSMA CD is the important protocol that is defined by the IEEE 802.3 Ethernet. It is an international standard. The MAC sublayer protocol does not guarantee the reliable delivery even in absence of the collision. The receiver may not have the copied the frame correctly. Next is CSMA CA procedure. The long form of the CSMA CA is the CSMA protocol with the collision avoidance. Last was collision detection, and this is collision avoidance. The long form, the figure shows the flow chart explaining the principle of CSMA CA. The station ready to transmit senses the line by using one of the persistent strategy. As soon as it finds the line to be idle, the station waits the time equal to the IGF, that is interframe gap. It then waits for some more random time and sends the frame. After sending the frame, it sets a timer and wait for the acknowledgement from the receiver. If the acknowledgement is received before the expiry of timer, then the transmission is successful. But if the transmission station does not receive the expected acknowledgement before the timer expiry, then it is incremented the back of parameter, wait for the back of time and senses the line again. That is CSMA CA completely avoid the collision. Next is controlled access. In the previous section, we have discussed about the random access approach for the sharing a transmission medium. The random approach is the similar to implement are useful in handling the light traffic. In this section, we will discuss the scheduling approach to the medium access control. There are three important approaches in the scheduling approach. First is reservation system, second is polling system, and third is token passing. In that, first is reservation system. The principle of reservation system you can understand from the basic diagram. In this system, each station transmits a single packet at the full rate RBPS. BPS is bits per second. The transmission from the station can organize into the frame of variable length. Before each frame, a reserve slot or reservation interval is transmitted. The figure shows the details of reservation interval R. The reservation interval consists of the M mini slots with one slot allocated to the each station. These minimum mini slots are used by the stations to indicate that they have a packet to transmit in the corresponding frame. The station that wants to transmit the packet by the broadcasting their reservation bit during the appropriate mini slot. All the station will listen to the reservation interval and then determines the order in which the packet transmits in corresponding frame would take place. The frame length would correspond to the number of stations which have a packet to transmit. If the length of packet is a variable, then it can be handled if the reservation message includes the packet length information. The reservation system that will discuss is called as the basic reservation system. The basic reservation system can be improved by using the time division multiplexing scheme. In the improved reservation system, idle time slots are allotted to the other station, which shows the system is negligible propagation delay. In first frame, only station 2 and station 4 are transmitting packets. In the figure, only station 2 and station 4 are transmitting the packets, but the middle portion of the station are also want to transmit it packets. So the frame get expanded from the 2 slots to the 3 slot. The maximum throughput of this system can be attained when all stations transmit their packet in each frame. The corresponding maximum throughput is P max is equal to 1 upon 1 plus V for one packet reservation mini slot. Next technique is polling. In this system, the station accesses the common medium one by one, that is by taking turns at the a given time slot, only one station will transmit into the medium. When the station finishes its transmission, then some mechanism is used to pass the right of transmission to another station which wants to transmit the next. There are different ways of passing the right of transmission from one station to the another station. A scheme in which M stations communicate with the central controller is outbound line is used for carrying the information from the central controller to the end users, whereas shared inbound lines are required to carry the information from user to the central computer. Thus, the inbound lines are acts as shared medium that requires the medium access control. The host computer acts as the central controller. It sends the control message which coordinates the transmission from one station. The central controller sends a polling message to the particular station. That station sends it the message on the shared inbound line. Once the process is over, the station gives go-ahead message. It is possible that the central controller may poll the station in the round robin or the serial fashion, or in the maybe according to some predefined rule. Next is the token passing. A token passing is the special frame which is used to authorize a particular station for the transmission. If the token passing method, the token is given to the station which is authorized to send the data. Thus, the station that has the token with its, it can transmit or listen. In the token passing network, each station has the predecessor or successor. The frame travels in one direction, they come from the predecessor and go to the successor. The token frame is circulated along with the ring when no data is being transmitted and the line is idle. The station which are ready to send the data will wait for the token. As the token circulates the first ready station, the ring will grab to the circulating token and transmit one or more frame. The station will keep sending and frame as long as it has been framed to send or allocate the time not complete. It then passes the token to the ring from which the next ready transmit station will grab it. This is the simplest possible token passing technique in which all stations have equal priority or right to send the data. In the practical system, some other features such as priorities and reservations are added. Next is channelization. In this multiple access method, in the total bandwidth of common link is shared in the frequency domain and the time domain through the codes. Depending on the methods of sharing, there are three channelization techniques. First is Fdma, frequency division multiple access. Second is Tdma, time division multiple access. And Cdma, that is code division multiplexing multiple access. First is Fdma, frequency division multiple access. In this method, the available channel bandwidth is shared by all stations. That means each station will have its own specific slot to reserve in the entire channel bandwidth. So the station uses allocated frequency band to send its data. Each band is thus reserved for the specific station. The concept of the Fdma is data link layer protocol, which uses FDM, that is frequency division multiplexing, at the physical layer. The guard band are provided in between adjacent frequency slot. In the guard band between the bands allocated to the station 1 and station 2, the guard band will avoid the adjacent channel interference. The FDM is used in the cellular phone or satellite network. Advantages of FDMA: all the station can operate continuously all 24 hours without having to wait to their turn come. The power of required transmission depends on the number of channel being transmitted. The signal to the noise ratio is improved due to the use of FM. And lastly, no synchronization is necessary in Fdma. Disadvantages of Fdma: each channel or earth station can use only one part of the total satellite bandwidth. In spite of the guard band being provided, there are some adjacent channel interference present. Next is, as the FM is used, it requires larger bandwidth, hence the less number of channels will be accommodated in the bandwidth of satellite. And lastly, due to the non-linearity of companders, the intermodulation products are generated. Next is TDMA, that is time division multiple access. In TDMA, the entire bandwidth can use by every user but not simultaneously. A station can use the entire bandwidth only for the allocated time slot. Thus, each channel is allocated a time slot during which it can send the data. Thus, the time is shared and frequency band is not shared. The Tdma is the data link layer protocol which uses TDMA at the physical layer. TDMA finds applications in the cellular phone and satellite network. Advantages of TDMA is since only one station is present at any given time, the generation of intermodulation product will not take place. And disadvantage of TDMA is TDMA needs a synchronization which makes it more complicated compared to the Fdma. Next is Cdma, that is code division multiple access. An alternative to the Fdma and Tdma, the another system is called as a code division multiple access is used. The most important feature of Cdma is each user is given a unique code sequence or the signature sequence. This sequence allows user to spread the information signal across the assigned frequency band. At the receiver, the signal is recovered by using the same code sequence. At the receiver, the signal received from the various users are separated by checking cross correction or cross correlation of the received signal which possible user sequence. In the Cdma, the users access the channel in the random manner, hence the signals are transmitted by the multiple users will completely overlap both in the time and in the frequency. The Cdma signal spread in the frequency. Therefore, the demodulation and the separation of these signals at the receiver can be achieved by using pseudo-random code sequence. Cdma is sometimes also called as a spread spectrum multiple access SSMA. In Cdma, as the bandwidth as well as time of channel is being shared by the user, it is necessary to introduce the guard time or the guard band. The Cdma does not need any synchronization, but the code sequence or the signature waveforms are required to be used. And next point is comparison of Fdma, Tdma and Cdma. The overall bandwidth is shared in Fdma. Overall bandwidth is shared among many stations. In Tdma, time sharing takes place, and in Cdma, sharing of bandwidth as well as time will take place. Secondly, in Fdma, due to non-linearity of the devices, intermodulation products are generated due to inference of the adjacent channel. In Tdma, due to incorrect synchronization, there can be an interference between the adjacent time slot, and in Cdma, both types of interference will be present. In Fdma, synchronization is not necessary. In Tdma, synchronization is very essential, and in Cdma, it is synchronization is not necessary. And next is code word is not required in the Fdma. In Tdma, also code word is not required, but in Cdma, code word is required. And lastly, in Fdma, guard bands between adjacent channels are necessary. In Tdma, guard time between adjacent time slots are necessary, and in Cdma, guard band as well as guard time both are necessary. Thank you.